Good morning. I have the impression boarding is completed. I'm your EAM application manager. My name is Péter Jurcsó. And on behalf of the CERN Asset and Maintenance Management Group, welcome our 14 billion year journey about maintenance around CERN. So when we are starting, we are really going back to time, far, 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 far back. I'm sure everybody in the room started at the same moment. We all started with the Big Bang. So we are on same terms, same history. You've probably heard these sentences around what is the oldest or the second oldest profession of the world. And I have the impression we can quite clearly declare that we are belonging one of the early ones. Because the first traces of maintenance dates back to 12,000 years ago. Somebody created stone projectiles for an arrowhead, and then, after they started to resharpen it to ensure that when they have to use it, it's properly maintained, it's fully capable to fulfill its functions, corresponding to the design parameters. So, first manufacturing, then maintenance, and this is already 12,000 years ago. Let's jump a bit further, but towards our time. 1954, we are after the Second World War, physics in Europe in ruins, and the physicists would like to have a facility to do science which is world-leading and can keep everybody in Europe. So for that, we have to create a green field, as you can see on the left side of the slide. It was really nothing where we started, and we had to build some big things together. And you see this giant magnet transported with a precision of a few inches around tiny village roads to get to CERN. And with that, we really started to set down the basis of new research and new technology. And this was slightly more than 70 years ago. The same magnet, what you've seen in the transportation, it's horizontally placed on the top of CERN's first accelerator, the synchrocyclotron, which was really the basis for over 30 years our research infrastructure. We also started to go in different domains around the science because we need new things. So CERN was relatively early when we acquired our first computer, our first IBM 709 machine in 1960. Anybody knows when this machine was released by IBM? It was 1959. So following year, we had the first thing. But probably for those who are sitting in the audience today, the next step is probably the cornerstone of our maintenance journey, and that's our first standardized work order form from 1963. When we have procedures, when we have rules, when we have a carbon copy form with 5 sheets to describe if somebody wants to have a work done on paper. Let's spring forward in the time and relate to those colleagues who yesterday talked about some mafias about data stream. For us, the computerized maintenance management journey started around 1983 when we had our first pilot project with Rapier. At that time, this was a company from the UK, and when CERN had this first trial, we got the computer with the installed software directly from the UK to have a way to start retroactive follow-up of maintenance. Of course, usually ask the question why this happened, and many organizations, the driving force was money. So this is why we went into this direction, and our first user group was the cooling and ventilation service of CERN. A few years later, we entered the era of the R5. This was used by the same services because they expected a slightly better product. And this was used to plan and follow up maintenance activities. And this was already installed on a standard computer on a microvax in our computer system, in the computer center. We are still using the same building as one of our facilities today. And to put in a historical perspective on the science field, this was the moment when CERN finished the nearly 17-mile long ring for the Large Electron-Positron Collider, which will become, a few years later, the home of the LHC. In the 90s, we had the evolution of the R5, and we ended up with the classic silo situation. Somebody saying that it's for the cooling and ventilation, and it's working, it's good. I would like to have the same, but just for me. And the other group wanted to have that's what I want to have for myself. So we started to have different separate instances of R5s around CERN used by different services. This was first in the technical domain, like electricity, machine tools, but also we started to have an instance for general maintenance. And the picture is probably not related at all to maintenance and R5, but related to the World Wide Web, which is coming from CERN, which was invented in 1989. And we can say that everything else, what we are seeing and hearing today, it's based on the internet, based on the web above the internet protocols, and this was one of the first open source and public domain things. And if today you are connecting to your Hexagon EAM instance, you are using a technology which is coming from CERN. Towards the end of the 1990s, we got to the age of the PC. We jumped into MP5, and we had the first version, which was running on a Windows PC. I'm sure some of you can still recall this start screen with the DataStream logo, related to the yesterday a few times mentioned DataStream Mafia. At that time, we have been already on board. As I mentioned, we had different instances, different silos, and that made the work together extremely difficult. So at the beginning of the 2000s, in a roughly 2-year project, we went through the big unification process to ensure that we are all speaking the same language, we are all using the same codes, and nothing is clashing. And as a result of that, we created a naming convention which is used for all asset codes around CERN. It could be a tiny piece for some electronics or a giant magnet for an accelerator, using the same naming convention with the same structure, which is defining the information on the parts for the replaceability and on the asset to have the uniqueness. And with that, we have one code which is really rules them all, a code which helps to find them, a code which brings them together, and of course, in work orders to bind them. As we went further, we followed the evolution of the tools. In 2007, we had the D7i. At the same time, we moved towards new infrastructures, new databases. And from the science perspective, you see this picture of the world's largest superconducting magnet. And maybe I have to point out this little thing. This is not dust. That's an engineer for the scale. In 2008, we are reaching the age of the LHC, the Large Hadron Collider, the world's largest scientific instrument, which is in 2 countries, and anybody who has the impression how difficult to maintain a bridge which is ending in one state and ending in the other one, imagine the same bridge which is, for example, in the US and ending up in Canada. We have the same kind of challenges with hundreds of millions of components in a 17-mile circumference tunnel, roughly 330 feet below the surface. And this whole thing really accelerating particles to the 99.9999999% of the speed of light. It's hard to imagine this scale. This is the satellite picture showing Geneva. You can see the airport as a scale. But as we are in the US, probably it's more scalable if I'm putting it over the map of Manhattan. So it's from the south of Manhattan up to the middle of the Central Park. And we are around Greenville, so put the same scale to have an idea how this feels in the local region. In 2009, we reached the era of the EAM. This was the first version of this application, which was running in a browser. You can see the teeny tiny Internet Explorer on the corner. And this was also the moment when we moved to Linux. And that's also the year which is the big celebration for the LHC, because that was the first successful year with the high energy physics runs. And as we reached towards 2011, we got a need. We started to have increased number of users. More and more people wanted to use the advantages of the maintenance management, of the asset management with the right software in the background. Lots of people have seen that we have a very, very complex user interface, but they wanted to use it in different places, not always just on the big screen. And they wanted to use something intuitive. We know sometimes it's not obvious where to find some fields, where to enter some kind of information, so we looked for something simple. And we know that complex systems requiring very extensive training to have very efficient and effective users. So we had to find some solution for that. And in 2011, we already starting the age of the mobile devices, so everybody want to have it in the pocket, on the tablet, and possibly without an installation. When we jump in 2015, it's a big turning point in the EAM usage at CERN. This is the year when we had first time more than 1,000 users using the EAM installation. It's really a big turning point with lots of equipment, store transactions, parts, and with a relatively small-sized 3-person support team in the background. Hexagon EAM is very well known about the flexibility and the connections. 2015 was our year for the big connections. We had our own tool for uploading data and helping the adaptation. This was the year when we had the connection to the S3 GIS to be able to look at the things in our installations. And that was the first time when we connected our control centers and our service desk to the EAM. If I'm taking the example of the CERN control center, this is like a street view. You can see it's quite a big room with different islands with lots of operators. But from our perspective, the important thing is happening in the corner. This is the part for the technical infrastructure operators. This is where all the alarm messages coming from cooling, ventilation, electricity, lifts, pumps. And they are getting this kind of alarm screen where every alarm message is connected to an equipment in EAM. If no equipment in the background, an alarm cannot be declared and accepted. But if something happening, the operator with a single click can create a new work order on that object. And this work order will be dispatched, and the operators, in a not too good year, they can create literally tens of thousands of work orders with a single click from the control system. In 2016, we went towards overhaul the new interfaces. This is the moment when we have our own EAM Lite in the version 3.0. And that's also the point when our radioactive traceability, which is fully based on the data in the EAM, is accepted by the national authorities as a single source of truth. They don't need any additional documentation. The information that we can extract from the EAM, that's what they trust and what they believe, which is really simplifies the work of our RP officers. Also, we've seen that we have more and more need to have a more effective tracing of the spare parts in the different activities. So we had different interfaces like a kiosk for self-service, but also have an equipment generator where using the configuration possibilities of the EAM can generate a new asset with the corresponding work orders on quality assurance, on certification, on installation right away from the beginning. In 2019, it was a big turning point. We made the EAM Lite open source. And in a certain sense, today I'm coming home. As you can see in the right corner, the first presentation on our open source components for the big public, it's happened here in Greenville at the Advoco Connect. So in a certain sense, back to the origins. In 2022, we had, of course, the name change to Hexagon. I should be very honest. Even today, 3 years later, a large majority of our users is still referring to the tool as Infor. And I don't know how long it will take until it will disappear from the memory, but this name change, it hasn't made a very big impression for the users. So, few numbers about our scale. In last year, we had roughly 3.2 million assets, 2.3 million documents, 350,000 work orders, but probably your favorite number is still the lower corner with the 0 modification, just relying on configuration and additional modules outside the base product. So if the new version is coming with new functionalities, in an ideal case, in a few hours' time, we can be upgraded to the latest version and have all the new features available for the users. If I'm thinking on the domain coverage, what are we covering with EAM? It's practically all the things that you can imagine. It's from the maintenance of accelerator, electrical installations, cooling, ventilation, management of office space, hotels, even our car rental facility for our visitor scientists is based on the rental functionality of the EAM. For the fire brigade, they are checking nearly 9,000 fire extinguishers every year using work orders related to the extinguishers and the corresponding functional positions. And all these things are in a single system, which is really a unified digital asset management platform based on the EAM product. As you see the line above, it sounds very similar to what you are hearing when you are thinking on ISO 55000, when we have an asset lifecycle, from the idea when we have a need until we have a proper elimination. And all these things are managed and controlled and followed through in the EAM system. So before something goes and become declared as waste, we can even look back, what was the original idea which generated the need to have this thing. And to be able to have this approach very efficiently, we need lots of connections towards the outside EAM world, and this is the lower line, using all the possibilities through the different connections, mostly using the web services of the Hexagon EAM, which allows these things function together. Of course, when we have these things, that's probably not enough to have a successful EAM journey. And we can really summarize our approach with the 3 Ps: the people, the processes, and the platform. You need all 3. If you are missing any of them, or it's not efficient enough, you will not have that result what you are hoping for. The first P, let's speak about the processes, standardization. I already mentioned that in the early 2000s, CERN spent quite a bit of time to ensure that everything is standardized in a sense of codification, to ensure that everybody can access the information and not running into the risk to have duplicates. And this is extremely important when we are having really a lot of users. Currently, more than 50 services are the daily users of the EAM, with last year about 3,700 users who logged in. And of course, we have the flexibility. We can define incredible ways of status changes and evolution of statuses for different objects. And all these things have been also standardized with standard flows, standard codification for the names. And all these things are based on the same naming convention coming from the early 2000s. Of course, we have to provide specialized services because some services want to have something very specific. So we have a classic a la carte menu where we put together all the things that we can provide based on the digital platform, and all these things are available for the users, but of course not everybody wants to use everything. When you go to a nice restaurant, probably you want to start with the first item on the menu and finish with the last dessert and eat everything in between. You are looking for certain elements that help your work. The second P is for the people. First, the usual question, which is always arriving, how many people can manage 3,700 users and millions of assets? It's a small team of 13 people. We are roughly 50% on the business side, with user support, with consulting and training. And we have the developers who can help the configuration of the system, managing the database underneath because we are running on-premise, and developing all the external features which are using the standard connectivity of the Hexagon EAM towards the outside world. For the people, usually neglected but extremely important and extremely valuable is the training. We have different blocks how we can provide training information. We have user meetings, which is about 4 to 5 times per year, about 60, 80 people. You can see a picture of one of these meeting audience, where we can provide information on new things, remind things how they are working, or showing new techniques. And we are having in-house training courses, one which is more towards the theoretical part, why we are doing things and what is the logic behind it. And we are running half-a-day modules for the different functionalities like equipment, work management, spare part management, kind of things, to really teach very efficiently in English and in French, because we are using with 2 languages, really the basics, how people can effectively use the tool, where to click, where to find the functionality what they are needing. The additional part of the people is the community. When we have 3,700 users, we cannot reach everybody directly. So we have the connection with the maintenance managers who are having the knowledge of the different technical domains. And we try to have so-called local administrators who can help with the most basic questions, can do the simple assignment. Okay, I have a user who now arrived and should have access with this specific user group which is in my domain. And all these things are really speeding up and creating a much better experience for all the end users, because they have somebody who they know and who can provide eventually with the first level of answer what they are looking for. Beside the people and the processes, we need platforms, and in our case that means user interfaces. And let's take a quote from Einstein from 1933, which said, everything should be as simple as it can be, but not simpler. So when we are taking the platform, we can look in the 3 direction. Everybody knows on the left side the base product, the mobile applications, the connected, the offline, the digital works in the middle, and our own EAM light on the right, because all the users are different, they have all different needs, and they only want to concentrate how they can do their work efficiently. So we have the different things, and we put our bet on our own approach for most of the users. From the 3,700, roughly 2/3 of them are using EAM Lite, either on a phone or on a tablet, with the really simple idea that we have the basic functionality, they have the way to have the data quickly, and in reality, sometimes even simpler than using a sheet of paper to make some notes. Of course, we are going towards more data, because the data is the basis of everything. The latest thing what we put in place last year, it was the monitoring of cranes using a low energy data network, which is transferring the data, and we can have units which are really put on the crane with a single battery, and they are autonomous for multiple years to sending the data and providing information what we need. So what are we doing with all these things? We're coming from the past with a history of over 40 years, and we are going into the future. We are having large, complex installations. We have extremely long lifetimes. For example, now I'm participating in a project when started the refurbishment of 80 magnets which are dated from the early 1960s. They have been still operational, but now it's time for an overhaul. It means that we will have data and things with extremely long lifetime, even pointing to a different generation. And the digital platform provides the continuity for us in this world. Of course, we are thinking always on the digital possibilities to have more things with the 3D design, with the 3D navigation, the virtual reality, for example, to prepare interventions, because lots of our installation has limited accessibility during run. And we are also really moving towards to have the digital twins, especially in the sense of the us-built and us-planned comparison. And we are running new tests with the help of other parts of ALI, especially in a sense of reality capture, how we can put the things together easily and efficiently on the field. And yes, this is a journey which never ends. It's not the target is the main thing, it's really the journey to ensure that we can continue to operate our really world-class installation, which is fully based on the capabilities of the Hexagon EAM platform, which really provides a very solid foundation, but which will not be efficient enough if we are ignoring the processes and the people. We are ready and open to have all the new features, the machine learning, predictive and prescriptive maintenance, and we have bold plans on the EAM towards the digital twins and other functionalities. And we hope that this journey will continue for a very long time, maybe hopefully for billions of years. Thank you.